Hello, all you network administrators out there trying to get smart in a hurry. Welcome to part one of Introduction to Layer 2 NAT. My name is Albert Mitchell, and we're going to be talking about how to handle duplicate IP addresses in industrial networks. So in part one, which means there's going to be another part coming, what is the problem to solve and how does Layer 2 NAT fundamentally work? And the idea is at the end of this, you should have enough information that you could implement this. What is the problem and why does Layer 2 NAT solve it? So sophisticated machines, like you see over there on the right, these robots, have these internal components, and each internal component has the same IP addresses. Now, and if you have multiple of these machines, you've got the same IP address floating around in each one of those machines. And that could be a problem because you've got duplicate IP addresses. If you're trying to get inside the machine and address those components individually. And this typically comes across as a packaged solution or software in a package. And so that's why I say it's the same software for every machine. In this case, we're looking at these robots, but it could be any sophisticated machine. When you get something delivered to you as a package with internal components that are IP addressable, this is typically what they look like. Now, this is my definition of a sophisticated machine. I know I talked about robots earlier, but really we're talking generically about any sophisticated machine. And in the sophisticated machine with multiple IP addresses, they're typically using Ethernet as an infrastructure, and there's an Ethernet switch in there somewhere. And so this shows they have internal networks, and typically they'll have some controller type device or something that has an internal and an external IP address. And the external IP address here, which is 10.0.0.100, would be unique. Somehow that would have been assigned by you, Mr. Network Administrator, to guarantee that it's unique and routable within the public domain. And if the only part of the machine you have to communicate with is the controller, then you don't really have a problem of duplicate IP addresses. You have a single device, which is on the public network, and it's unique, no problems. And then, what we typically will see, if you just have one machine, of course, you don't have a problem. But if you have multiple machines, you have a potential problem because you can see that in these sophisticated machines, the components are all the same. And I say like we're duplicating IP addresses, and what you'll see here is that internally, these machines all have the same IP address for every component. And that makes the software a lot easier to write. And before we get into how Layer 2 NAT works, we're talking about, duplicate IP addressing in these machines. One other way that it's been solved traditionally, if you have to communicate with a component inside the machine, is you can just add a Layer 3 device. And by a Layer 3 device, I mean either a router or a firewall. And these devices will implement like NAT or PAT, or traditional IPv4 practice. Now, they are more complex than an IE switch or a switch in general, and it is one more device to manage, which is not good. So let's get into the Layer 2 NAT fundamentals on IE switching. Layer 2 NAT for IE switching is a one-for-one IP address translation. It's not one for N. It doesn't do PAT. It doesn't do Layer 4 port address translations. It's a Layer 3 IP header IP address translation. It's one for one. Works at line rate. Works bidirectionally. That means whatever's coming from the outside for the inside is translated, and whatever's coming from the inside for the outside is translated. We're going to use these terms a lot. Public and outside are referring to what's unique and routable, and private or inside is determined to what is often inside the machine and is duplicated across machines. Layer 2 NAT does work with ICMP and ARP, and we're going to call it the fix-up. And that's because with ICMP ARP, these are not the only IP protocols that put the IP address into the payload, but Layer 2 NAT does recognize that they have special significance and will actually go into the payload, find the IP address, and fix it. And in these examples, I use 192.168.1.x a lot, but it could be any IPv4 address. It's not just 192.168. Also, within the industrial switches, the way we've solved it is we have a special component for doing translation that is separate from the switching ASIC. So what this means is the translation and the forwarding are not really related. Forwarding decisions are made by the ASIC without regard for any knowledge that it's going to be translated. And you have to see now in the path, you see that the downstream interfaces or packets coming from the downstream to the upstream are first layer 2 switched using quote unquote internal IP addresses or the inside IP addresses. And it's not until they get through the translation component are they translated. The same thing from the outside is that it's an outside IP address. It comes in and gets translated to the inside, and now it gets layer 2 switched or layer 3 routed, depending upon what it's going to do. So it's important you understand that the two are not the same. They're distinct, and where in the data path the translation component exists. And we can't translate on every interface. So for industrial switching, which interfaces support translation is important. Please consult your data sheets to determine that, or the configuration guide for your device. So we're going to show you how to use layer 2 NAT in a network and how it fundamentally works by introducing a problem. We want to communicate with one of the devices inside the machine. We're going to communicate with the HMI component, and it's using 192.168.1.3. And we can't change that. It's hard-coded. So we're going to have this data collection app that wants to communicate with the HMI. And you, Mr. Network Administrator, have defined a unique IP address in the public domain for the HMI, and you've given it 10.0.0.99, and this is an example of the layer 2, the CLI configuration command for how you would actually do the translation. There you go, it's known as 10.0.0.99. We've got to make one change. We got to add an uplink. So now the machine, the industrial switch here has to communicate directly with the zone switch, or it needs a layer 2 interface. Anyway, now the switch would be in both the public and the private space. So now a slightly different picture showing just the HMI over there on the right, the layer 2 NAT switch, and then the zone switch, and the data collection app all the way on the left. Note that if you look below the layer 2 NAT switch, you'll see the CLI configuration. This is what we call an instance. It's really like a structure where you define how the layer 2 NAT translation is supposed to work. And we've given it a name called HMI Machine 1. And you can see that in orange there, we have an outside translation for the zone layer 3 gateway. And we're going to translate it into 1.1. And from the inside, we have an IP address translation for our HMI, which we already stated is going to be translated into 10.0.0.99. Now, if you go back to the top right, you'll notice that the HMI machine internally has its own gateway defined for its subnet because it's on a class C. You'll see that it's got a 1.1 IP address internally for its gateway. And now going back to the CLI configuration for the NAT switch there on the bottom. Now our uplink is gigabit 1/1, and we're going to apply the layer 2 NAT HMI machine 1 instance to VLAN 3004. Now this is a trunk interface, so the VLAN 3004 is going to be tagged, so we have to tell it which VLAN to work on to look for these IP addresses. Because VLAN 200 is not going to be translated. So packets going in and back and forth on VLAN 200 will not be impacted by any translation. Note, right, this is being done on VLAN 3000. The switch is making a layer 2 forwarding decision based on MAC addresses. Okay, this is why we call it layer 2 NAT. So let's watch this in action. So we've sort of taken the same topology picture, we've moved some of the configuration up to the top so we can watch this work. So it starts with the application to collect data, wants to communicate with the HMI machine. In this case, it's going to send a ping request. Now, it probably wouldn't normally do that, but it doesn't really matter. We're just looking for how the translation works. And note that when it gets to the zone layer 3 switch, it's routed, so the source and the destination MAC address change. It puts its own source there for its layer 3 interface, and says the destination is 10.00.99 because it also knows the HMI machine 1 as 10.00.99 because that's what the data collection application wants to talk to. So anyway, off it goes into the switch where it hits the translation, and then once it comes through the translation, it comes out the other side. We hit the one rule to translate, 10.00.99 into 192.168.1.3, and we did not change the MAC addresses because it's layer 2 switch, so the source and destination MAC addresses remain the same, and HMI machine 1 receives the echo request. Now, what do you do if you don't have the MAC address for your gateway? Because it has to respond to an IP address 10.17.216.130, which is outside of its subnet. So it now needs to figure out, okay, I got to figure out how to put together my packet in order to respond. So it's going to ARP for its gateway. Now, the ARP request is now going out, and its source is 192.168.1.3. And you'll notice that once it goes through the translation there, that both IP addresses have been translated. And now the gateway will now respond. It's saying that 10.0.0.1 is at its MAC address CC, and that goes through and that gets fixed up as well. So both ARP request and ARP reply are both fixed up, and the gateway will now receive that the HMI receives the gateway's IP address and MAC address. So now it can now respond to the data application ping with by putting in the destination MAC address of the gateway, and the destination IP address is of the data collection app, and it's using its own source. Now, when it goes back, the layer 3 headers are for the HMI machine is translated in 10.0.0.99. The destination IP address for the data collection app is not touched because there's no rule that says we have to translate that, so leave that untouched. And then that gets layer 3 routed through the network eventually to the data application. Now, I used ping in this example, but it could have been any application, any UDP or even TCP applications work. So again, it's working just in the layer 3 header, and for the most part ignores the payload, except for where things are going to be fixed up specifically. So let's take a look at the other parts of the instance definition. So permit all and fix up all. So fix up all, we talked about this already, is you can fix up ARP and ICMP. There's no reason to not just fix them all up. So that's why I recommend fix up all. The next part is permit. So permit allows you to essentially use an ACL, if you will, but it's a pretty blunt instrument because it can act as a deny. In this case, I did permit all, and that allowed the untranslated IP address for the data app to come in. So in this case, because it doesn't need a rule. Anything that comes in on VLAN 3004 is permitted, right? Otherwise, it can act as a deny all if you don't have permit all. So it's a pretty powerful thing to use. And so you can see the permit, mostly what we're talking about when it comes to powerful, we're talking about the unmatched portion. So if you don't have permit all or don't permit unmatched specifically, then it must have a IPv4 translation rule on the VLAN in order for it to be permitted. If it does not, it is dropped. Okay, so it's a pretty strong deny statement if you don't have unmatched. So this is going to wrap up our short video here. Remember, these IP addresses are done on purpose. Layer 2 NAT for IE switching works 1 for 1, but it is a single box solution and it works at line rate. Now, you can get a lot more information on Layer 2 NAT by reading the Layer 2 NAT configuration guide on cisco.com for industrial switches. If you want to see Layer 2 NAT used in a solution environment, the Connected Plant-Wide Ethernet, CPWE, has a section on how to use Layer 2 NAT, and that shows you as part of a bigger solution. If you're interested in looking at other networking for industrial, we have our own YouTube channel. There you can see it. And remember that Layer 2 NAT does not do NAT-PAT. Hey, thanks for watching all the way to the end.